Bismillahirrahmanirrahim. In this video, I will solve a chi-square test to test the hypothesis that the variance of the normal distribution is equal to a constant number. Let's start. So we have a sample that is based on the we have a sample that has 7 observations. The standard deviation of the sample is 3. We test the hypothesis that the sample of the standard deviation is equal to 2 and the alpha value we have taken is 0.05. Now we come towards the test statistic. This is a test statistic. Chi-square is equal to n minus 1. N is the sample size multiplied by s square. This is the variance of the sample. Usually it is given in this question that variance of the standard deviation of the sample is equal to 3. This is the standard deviation. However, in some of the cases you may have the sample values. For example, you may have the sample value equal to 6, 7, 10, 13, 19 like this. Then you will have to compute the variance or the standard deviation by yourself. In order to make this video short and you know how to calculate the variance, so I took it directly equal to 3. So now it is divided by sigma naught square, that is our stated value for which we will formulate our hypothesis. So first of all we will formulate our null. So first of all we formulate our hypothesis. We say h naught, that is our null hypothesis, then full column we say that sigma naught square is equal to 2, that is our null hypothesis. And then alternate hypothesis, it is represented by sometime h1, sometime it is represented by h of a, and again a full column. Then we say that sigma naught square is not equal to 2. It's a two-sided hypothesis. Okay, it's a two-tail test. So now after formulating the hypothesis, we will go towards our second step, that is the test statistic. Now we will compute the test statistic. It's quite easy. Just put the values. How many observations? 7 minus 1. This n is 7. 7 minus 1. Then write the s square. S square is basically the variance that of the sample. In our case it is 3. When we'll take the square, it will become 9. Divided by sigma naught square. It is the stated value or the constant we have taken. So it is equal become 2 square. That will be equal to 4. Then we will solve this expression to get our chi-square value. So I did the calculation. 6 multiplied by 9, 54. 54 divided by 4, it is equal to 13.5. So we will write that chi-square test statistic value is equal to 13.5. Now after that, what to do? Now we will have to work on the rejection criteria. In the rejection criteria, you will have to remember this figure, that chi-square alpha by 2. This is the tabulated values. Both of them we will check from the table, chi-square table. So we will place the chi-square alpha by 2 value on this upper tail and 1 minus alpha by 2 value on this lower tail. So this is the decision rule. We will reject the h naught null hypothesis is if our chi-square value is less than chi-square alpha by 2 and minus 1. So let's find out this one earlier. So we have chi-square, then alpha by 2, alpha is 0.05, so 0.05 divided by 2 comma n. N is the 7. 7 minus 1, this is equal to 6. So this becomes, so chi-square 0.025 comma 6. I will check this value in the table. First of all I will also write it down. So chi-square 1 minus, so basically alpha by 2 is 0.025 comma n minus 1, this it's equal to 6. So it will become chi-square 0.975 comma 6. Let's go to the table and then we will pick these two values from the table. So here you can see percentage point of chi-square distribution. So first of all we have 0.025 on this horizontal axis and v is the degree of freedom on the y-axis. So look at there, 0.025 on the x-axis and along with that 6 on the y-axis. We got 14.45. This is the value of the upper tail. Let's write it down, 14.45. We'll write it down for the A's, 14.45. Now for the second value, that is 0.975 and 6. So 0.975 and again 6, we got 1.24. This is our value for the lower tail. So I will write here 1.24. Now what we will have to do, we will have to check that where our value lies. Our value is 13.5. It lies somewhere here. This is equal to 13.5. So what will be your decision? Since our value lies in the good region, so in this case, what will be our decision? Let me write it. So our decision is fail to reject the null hypothesis because our value test statistic value lies between the upper bound and because our test statistic value lies between the upper bound and the lower bound. Now we'll come towards the conclusion. Now what will be our conclusion? That it is concluded that the sample variance is equal to 2. That what we make in the hypothesis, and we prove it that scale not is equal to 2 has been proved to be good. Thanks for watching video. Bye.